In this activity, we'll be creating a program that utilizes the TypeState pattern. Once you're ready, load up Visual Studio Code and we'll get started. Once Visual Studio Code loads, navigate to your Activities directory. We are on Activity 34, so double-click on a34.rs. Once the activity file loads, review the topic and program requirements. Attempt to implement a solution on your own with the video paused. Once completed, resume the video and I will demonstrate my implementation as well as provide insights to the activity topic. All right, let's get started. This activity topic is on type states. We have a summary here. An airline wants to reduce the amount of lost luggage by ensuring luggage is properly tracked. So we'll be creating a luggage tracking system and we'll be using type states to implement the tracking. If we take a look at our program requirements, we need to implement a luggage tracking system using the TypeState pattern. Each piece of luggage has a tracking ID, so we need to make sure we monitor that. And the luggage goes through multiple states at the airport. So here's all the states that are available for the luggage. And we can optionally use generics for each state. I'm going to do this implementation without using generics, since it'll be much cleaner and simpler to use for this particular activity. The first thing we'll need to do is create the structures needed for these states and the luggage. So what I'm going to do is create a new type for the luggage ID. That way we don't get our IDs mixed up. We'll also need a luggage structure, and that's just going to use a luggage ID. I want to derive copy and clone for this one. The luggage ID is just a new type, and that way we can't accidentally use an invalid luggage ID while we're managing the luggage types, since it'll get type checked. So the usize, we can just type usizes anywhere, but it's going to be a little more difficult to type a luggage ID anywhere. And Rust will ensure that we don't do anything wrong with that. We'll then create the types that represent these states. So we'll have check-in. That'll take a luggage ID. And all of our states will have a luggage ID. So we'll have check-in, we'll have onload, we'll have offload, and we'll have awaiting pickup. And we'll also have end custody. So these are all the states that are referenced in the instructions. The next thing I'm going to do is implement the luggage structure. So we'll just create a new luggage, and it'll have a specific luggage ID. And we'll return the luggage with that ID. We'll then have our check-in function to check the luggage into the airport. It's going to return the check-in state. Now, when we create the check-in state, we need to supply the luggage ID by accessing the field. Since the luggage is a tuple struct up here, we can just use .0 to access that. The next state we need to implement is the check-in state. So after we check in the luggage, we need to load it onto the plane. So we'll name our function onload and return the onload state. The onload state also takes a luggage ID, so we'll just access it directly and return the state. The next state we'll implement is the onload state. Once we have an onload state, the only other option is to offload it at the destination airport. So we'll return the offload state. So we'll do offload the luggage ID. The next one will be the offload state needs to get implemented. After the luggage is offloaded, it's going to be placed onto the luggage carousel. So we'll have a carousel function, and we'll transition to the awaiting pickup state. So this is the state where the passenger is waiting around to pick up their luggage. Finally, we'll implement the awaiting pickup state. And we'll have a pickup function, and this is when the passenger picks up their luggage. So that's going to return the actual luggage itself, and we're also going to return a new state for end custody. So that'll be a tuple, and we'll return the luggage with the proper ID, so we'll get the correct luggage. And then we'll end the custody with the luggage ID as well. The end custody can be used for logs and monitoring and all that good stuff. In our main function, we'll create a new luggage ID. We'll just do ID number 1. We'll create a new luggage. We'll use that ID we just made. And then we're going to run through the process. So we'll have a luggage, and we'll check it in. We'll load it onto the plane. A flight will occur, and then we'll offload it. After it's offloaded, it'll be placed on the carousel. Now that it's on the carousel, the luggage needs to get picked up by the passenger. So we can do luggage.pickup, and that'll get picked up by the passenger. For this demo, we don't need to worry about logs or anything like that. So we're just going to throw away the end custody. So luggage.pickup, if we want to specify the exact type, we have luggage. We're going to ignore the custody, and then that'll be how we access the actual luggage itself. We don't need to print anything for this program, but I am going to do a cargo check to ensure that we've implemented correctly. So with type states, remember that the compiler is actually going to check all these function calls and ensure that everything's done in the correct order. So I'm going to do cargo check to make sure that's the case. To open up a terminal, we'll go up to Terminal, New Terminal. We're on activity 34, so we'll do a cargo check --bin A34. So it looks like I have a few errors. I'll hop back to the code and see if we can figure out what's wrong. It's saying that we don't have an onload structure, so let's check. It looks like I accidentally put onlog instead of onload, so we'll just change that. And we'll do a cargo check again, and everything checks out. So we are utilizing this type state pattern correctly. Before finishing up, let's take a look at the code. We're creating our luggage structure here, and here are our states that we're using for state transitions. We scroll down. For our luggage implementation, we have a check-in function, which returns the check-in state. For our check-in state, we have an onload function, and that just returns the next state, which is onload. This continues to the onload state. The only function available is offload, which returns the offload state. It's then placed on the carousel and awaiting pickup. After awaiting pickup, we can call the pickup function where the person picks up their luggage, and we end the custody by returning an end custody state. In our main function, we create a new luggage. We then check it in, onload it, offload it, place it on the carousel, and finally, it gets picked up. All of this is checked by the compiler, so if we do any of these in the incorrect order, we'll get a compiler error. This helps ensure that your program runs properly and consistently, even through edits and updates. If you'd like to see the generic solution to this, you can look at the solution file for activity 34, which has both this solution and the generic solution within the same file. This concludes the activity on the type state pattern. I'll see you in the next presentation.